Welcome back, children. Today in this session we are going to see class 9 mathematics. Already you know we are in the chapter polynomials, chapter 2 polynomials. So here first we have completed the classification of polynomials. Okay, classification of polynomials. That was the first topic. Under that, Ch-2.1 finished. Next, zeros of polynomials. Okay, this also we have finished. This is under the exercise 2.2. So now coming to the remainder theorem. Okay, and then factor theorem. So these two we have to see in this class. Okay, so remainder, first of all I would like to tell you the spelling remainder. Okay, most of the students writing wrongly as reminder. Here they are missing this A. Okay, so that's you should take care. This is the remainder. Okay, now giving you a better understanding of what is division. Then we come to understand the remainder and remainder theorem. Okay. First, 10 divided by 2. Okay. What we do? 10 is the bigger number, so keep in the dividend, and 2 is the divisor. Then 2 5s are 10. The remainder is 0. What we are doing here to get the remainder? Okay. 2 5s are 10. Okay. And then we are writing 0 here. How? By subtracting that. There is no subtraction, but even though we are understanding that 2 5s are 10, so from the dividend 10, when we subtract this 10, then only we are getting the remainder 0. So that is what the matter there. Okay. Suppose 10 divided by 7. What happens? 10 is the dividend, 7 is the divisor. 7, how many 7s are there in 10? Only 1. That we know. So 1, 7. 7 and 7. What's the remainder? 3. How we are getting that? Because we have to subtract 7 from 10. So 10 minus 7 is 3. So this is what happening there. Okay. Why I am writing the subtraction sign here? Because I am going to inform this in the upcoming problems. Clear? So this is what we are doing, and we can write this 10, the dividend, as what is the quotient here? 5. 5 is the quotient. Spelling Q-U-O-T-I-E-N-T, quotient. Okay, and this is called divisor. And this 10 is called dividend. Clear? And this is called the remainder. That you know. Remainder. Just now I told you. So how we can write this 10 is equal to divisor 2 into the quotient is 5 and then plus the remainder 0. So that's why dividend, capital D, small d. In short, this dividend you can write like this. Dividend is equal to divisor, you see dr. So divisor into quotient Q. You put bracket to avoid confusion, plus the remainder. Okay, so this is the format, this is algorithm. Okay, the division algorithm. Dividend is equal to divisor into quotient plus remainder. You see, like that only it comes. And here in this sum, dividend is 10. Okay, what is the divisor? 7. And what is the quotient? This is the quotient, 1. And then plus the remainder is 3. You see how I am writing? Using this equation. Okay, wherever you see equal sign, that is equation. Am I right? So 10 is equal to 7 into 1 plus 3. So divisor into quotient, 7 into 1, 7. And then plus the remainder 3, you get 10. So this is the, we are going to do like in polynomial. Okay, this is numbers. So polynomial, what happened? So this is the, just for your information. This and all you know, just recalling the prior knowledge before getting into the polynomial division by another polynomial. Okay, these are not only to take just information. And now, when we come into the polynomial by another polynomial, for example, 2x cube plus x square plus x. So this is a polynomial when divided by another polynomial x. So that means here 3 terms, whatever it may be, and this is a monomial. So when we divide, what happens? You can write like this: 2x cube plus x square plus x whole divided by x. And you see how I am doing: 2x cube by x plus x square by x plus x by x. So what I have done here, simply the divisor is x. For how many terms are there? 3. So each term separately I am dividing by x. So that is equal to that. Okay, you know, when we write like this, 10 by 3 plus 7 by 3, you can write this as 17 by 3. But you know, so in numbers, so number means we can add, but these are unlike terms. If it is like terms, then we can add. For example, 10x by 3 plus 7x by 3. Then we can write this as commonly, the common denominator is there. So 10x plus 7x, then we get 17x by 3. So these are the, you know. So but here different terms. So variable is x, but the term is different. So each we have to divide by x separately. So what happens? Now x cube is in the numerator, but x is there in the denominator. So x cube by x, what happens? So 2x square into x, like that we can write this by x. So x cancel, and plus x into x. So for into, just I put dot. Okay. So x cancel, plus here 1x, here also 1x. So what will come here? 1. So 1, 1. This one. 1 by 1 is 1. So finally we get 2x square plus x only here. So plus 1. So when we divide a polynomial by another polynomial, even there is only one term x, this is also a polynomial which is called particularly or specifically monomial, that you know. So when dividing by polynomial, so this is the way you will get the final answer like this after dividing this by x. So like that, you can move to the next one. You take 3x square plus x plus 1 divide by a polynomial x. What happens? 3x square plus x plus 1 whole divided by x. So we get 3x square by x plus x by x plus 1 by x. You see, when we do like this, The last one is 1 by x. So 1 by x means is not a polynomial because the variable is in the denominator. It is not a polynomial. We cannot get another polynomial. So to avoid that, you can if you proceed this, what happens? This is here x square and denominator x. If you cancel 1x, okay, what happens? 3x you will get. Okay, both in numerator and denominator, if we cancel x, you get 3x. And here it is cancelled, so 1. And here 1 by x is there. So to avoid this, okay, put a bracket and you can write like this: x into 3x plus 1, okay, plus x into 3x plus 1 plus 1. Okay, if you try to multiply, you will get this 1. You see, x into 3x is 3x square, okay, and the same x into 1, you will get x. So 3x square plus x, first two terms we got it, and then plus 1 here, plus 1. That's the third term, constant. Clear? So like that we can write. So this is the way of writing this type of division. And shall we move to the next remainder theorem? Clear? So dividing a polynomial by another polynomial. Divide p of x by g of x, where p of x is equal to x plus 3x square minus 1, and g of x is equal to 1 plus x. Okay, so let us see what will happen here. When we divide a polynomial by another polynomial, p of x, g of x, they are naming like that. Okay, they are in same variable x but different polynomial. This is you see how many terms? 1, 2, 3. 3 terms polynomial, and here only 2 terms polynomial, which is greater this alone. And you have to see the degree. Clear? By seeing the degree only, we can compare that which is greater and which is smaller. Here 3x square. Don't observe only the first one. Okay, we have to see all the terms and come to the conclusion what degree it is. So here x square term is there, therefore degree is 2, and here the degree is 1 because 1 plus x. So x power 1, so 1 degree. So this is the greater one. So when we divide p of x by g of x, so we have to divide by bigger by smaller. So what we do? This is an actual division. You see what we are going to do. So this is star. So from here we have to take. Clear? Divide p of x by g of x, where p of x ungiven and g of x is also given. So here you have to take 3x square plus x minus 1. You see what I am doing? The solution. P of x by g of x we have to divide. So even though they have mixed the terms, not in arrangement, so you have to arrange. It's our duty. So first x square term and then x term and then constant. Clear? And you have to take like this, draw a line and take the divisor. Okay, so this is the dividend. The higher degree you have to take as dividend. The smaller degree you have to take as what? Divisor. So even though here 1 plus x given, I am taking that as x plus 1. Okay, you have to take in a descending order. That is order. Okay. So first you have to focus here. So many of them are not observing the way of doing. This is the method. Method of doing the actual division, polynomial by another polynomial. So focus here. 3x square is the first term. In this dividend area, 3x square is the first term. And here in the divisor, which is the first term? X. So what I am going to do? I am going to do 3x square by x. So first term of dividend by first term of divisor. Clear? So 3x square by x. What do you get? 3x. Am I right? So write that in the quotient part, 3x. So now you have to multiply each term of the divisor with this 3x. So x into 3x we get 3x square. 1 into 3x, 3x. Clear? And draw a line, leaving a little bit gap under this. So you have to draw a line like that. 3x square, what happens? Subtract. You have to change the sign in the bottom. You know why? I already told you. In the normal division, 10 when divided by 3, 3 3s are 9. The remainder is 1. How we are getting? Subtracting 10 minus 9. So subtracting 9 from 10. So we usually we not write this minus sign and all. We don't write that. But here you have to understand, because this is number. By the practice, you come to understand what we have to do here. 10 minus 9 is 1. But when coming to polynomial, term by term, okay, so you have to do that by writing the sign. So you have to change the sign of the bottom polynomial. What we get in the bottom? 3x square plus 3x. So we have to change the sign. Plus becomes minus and this plus becomes minus. The bottom terms you have to change the sign. So that is the way of doing, that is method. In numbers you can understand easily, but here it is polynomial. So 3x square minus 3x square gets cancelled, and x minus 3x, what happens? Minus 2x. So you see here, x minus 3x. This is minus, okay. So x is common. So 1 minus 3, clear? So x into 1 minus 3 is minus 2. So it becomes minus 2x. We cannot do every time like this. We have to understand the numerical as it is. And the term is x. So directly we can put minus 2x. And this is minus 1. So now this is minus 2x. The first term of this polynomial minus 2x minus 1 is minus 2x. And here always the first term is x in the divisor. So we have to do like this. Minus 2x by x. We get x cancelled. So minus 2. Am I right? So you have to write minus 2 here. And you have to multiply each term of the divisor by minus 2. So x into minus 2, what you get? Minus 2x plus 1 into minus 2, what you get? Minus 2. I always told you, leave a little bit gap and then draw a line. So minus becomes plus and minus becomes plus. Just you have to change the sign. Why is that? This is the method. I already informed you. Okay. Minus 2x plus 2x gets cancelled. You can cancel. You can, no need to strike, but for our understanding, we are doing it. And this is minus 1 plus 2. What happens? So plus 2 minus 1. Like that also you can take it. 2 minus 1 or minus 1 plus 2. Both are 2 minus 1 or minus 1 plus 2. Both you will get 1 only. Correct? So this is the way of understanding. Don't get confusion. So here 2 minus 1, 1. That's all. Why I stopped up to this? Because no variable is there. Only constant. But here the variable is there. Up to this, here minus 2x means both are equal degree. Here also minus 2x. So x power 1. Here also x power 1. So up to that, when the degrees are equal, we can proceed. After that, stop. So here no variable, so you can stop. So that the remainder is 1. So you can write what? P of x is equal to what? G of x is the divisor into quotient as q of x. We can name it small q for quotient plus r of x is remainder. Small r refers to remainder. So this is nothing but p of x is 3x square plus x minus 1, and g of x is nothing but x plus 1. So you have to put bracket, and then p of x is what? 3x minus 2, that is the quotient. So into this, no need to write here because we are writing within the bracket. So 3x minus 2 plus, what is the remainder? 1. That's all. So 3x square plus x minus 1 is divided by the divisor x plus 1, and the quotient is 3x minus 2, and the remainder is plus 1. 1 is the remainder. So when we simplify this right hand side, what we are going to get? The left hand side. So x plus 1 into 3x minus 2, when you multiply and simplify, you get definitely the left hand side. Clear? So 1 is the remainder here. So that's why I just the last example previously plus 1, I told you to put it separately, because that 1 will become the remainder. We cannot divide by x. If we divide, what happened? 1 by x only. 1 by x is 1 by x. So to avoid that, so in a polynomial form, if you want to write, then the variable should not be in the denominator. So this is the way of writing. Clear? Okay. So now you have learned how to divide a polynomial by another polynomial, and we got the remainder 1 here in this term. Now I am going to teach you now the remainder theorem.
Start.
Finding remainder when p of x is divided by g of x. Okay. Now solution. You take the same p of x given here, that is 3x square plus x minus 1, and g of x, that also same 1 plus x, and we take that 1 plus x as x plus 1. So just we have to find in rough column x plus 1 equal to 0, then x equal to minus 1. Okay, so simply finding 0 of x plus 1. So x plus 1 is the divisor, that is g of x. So you have to find the 0 of g of x. So how to find 0? So x plus 1 we have to equal to 0, and then we get x equal to minus 1. So minus 1 is the 0 of x plus 1. Clear or not? So now substitute minus 1 instead of x. What do you get? 3 into minus 1 whole square plus of x instead of x minus 1. So to avoid confusion, put bracket and then minus 1 as it is. This is there. And then 3 into minus 1 whole square, that becomes 1. So 3 into 1. Here plus into minus 1 is minus 1. So put minus 1. And again minus 1 is there already. So that also you have to put. So then 3 into 1 becomes 3. And then minus 1 is minus 2. So 3 minus 2, and the final answer 1, which is the remainder. You see, in the actual division also we got 1 as the remainder. And when we apply the remainder theorem, this is the way of, this is the method of finding the remainder by using the remainder theorem. So you have to find the 0 of the divisor and you substitute in p of x. Then we get the remainder. You see, here also 1, the remainder, and here also the remainder is 1. So what says remainder theorem? If p of x is divided by the linear polynomial, so p of x is any polynomial in variable x. So if p of x is divided by the linear polynomial x minus a, why we are saying x minus a as linear polynomial? Because x power is 1, the degree is 1. So x minus a, linear polynomial. Then the remainder is p of a. P of a. Just we put a instead of x. P of x is the given polynomial. For x, put a, that is p of a, which is the remainder. So that only the remainder theorem says. So Here what I get? X plus 1, here x minus a. The divisor there x plus 1, here x minus a. A is any real number. So x plus 1 equal to 0, then we get x equal to minus 1. So which is the 0. So like that. Just we substitute minus 1 instead of x. So p of minus 1 is 1. The value of the remainder is 1. But the remainder is p of minus 1. And the value of p of minus 1 is 1, which is the remainder. Clear? So p of minus 1 which is equal to 1. Both are equal sign. P of minus 1 equal to 1. So this is the remainder value. So here instead of x in the given polynomial, we put a, then p of a is the remainder. Clear? So the notable points: degree of p of x greater than or equal to 1. The p of x is a polynomial, so that the degree should be greater than 1 or equal to 1. When p of x is divided by g of x, which is the greater degree? P of x only. So the dividend should have more degree, okay, than divisor. So like that we have to consider. So degree of p of x greater than degree of g of x. Clear? And we shall move to the exercise 2.3. Now coming to exercise 2.3, the first question: find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. So options are there. The first option x plus 1, that is this is g of x, like that. So let p of x, we have to name the given polynomial as p of x. So p of x is equal to x cube plus 3x square plus 3x plus 1. When p of x is divided by x plus 1 is the divisor given here. So when p of x is divided by x plus 1, the remainder is p of minus 1. This is because of by remainder theorem. Okay. How we are saying here? The explanation: x plus 1 is the divisor, so we have to equate to 0 and we get x equal to minus 1. Clear or not? X equal to minus 1. So just we have to find the 0 of the divisor, that's all. And we have to substitute. What the remainder theorem says: when p of x divided by x minus a, then the remainder is p of a. So x minus a we have to equate to what? X minus a we have to equate to 0, then we get x equal to a. Clear? That is the remainder theorem. When p of x is divided by the linear polynomial x minus a, the remainder is p of a. Remainder is p of a. That is the remainder theorem. So how to find that p of a? X minus a we have to equate to 0 and we get x equal to a. So a is the 0 of x minus a. So p of a is the remainder. For x, put a. P of a is the remainder. This is what remainder theorem says. So here, just we have to find the 0 of the divisor x plus 1. Okay. This is the first sum. So I am explaining you this, but in the other sums directly I will do it. X plus 1 equal to 0, then we get x equal to minus 1. So given x plus 1, we have to equal to 0 and we get x equal to minus 1, and that is the 0 of x plus 1. So here we have to substitute minus 1 for x. So in this, okay. And for every x, the same minus 1 you have to substitute. Minus 1 whole cube plus 3 into minus 1 whole square plus 3 into minus 1 and then plus 1. So you see what I did? Instead of x minus 1, here also minus 1 whole square, minus 1 and then last plus 1. So minus 1 whole cube, what we have get the answer, what you get the answer? Minus 1 if you apply cube, minus into minus into minus, minus only. So for 1 if you apply cube, 1 into 1 into 1, 1. Okay, you know, if the power is in even number, then minus 1 becomes plus 1. If the power is odd number, then minus 1 becomes minus 1. And here plus 3, minus 1 whole square is 1. That's all. And plus into minus, minus 3 into 1, 3. And then plus 1. And here we see minus 1 plus 1. You can cancel it or always wait for another step. Minus 1 plus 3 into 1 plus 3, and this is minus 3 and then plus 1. You see, minus 1 plus 1 plus 3 minus 3. What do you get? 0. Alright? The remainder is 0. So this is the remainder p of minus 1 and the value of the remainder is 0. Correct? So directly we have found the remainder of p of x, the given polynomial. When divided by x plus 1, the remainder is 0. When you do in actual division also, you will get the remainder as 0. So remainder theorem says directly we can find remainder. That's all. And coming to the next one. If you find in actual division also, you will get the remainder 0. Just I have compared in the previous example, the first step. Beginning itself, we have divided a polynomial p of x by g of x, and we got the remainder 1. And by applying that remainder theorem also, we got what? The same remainder 1. And then coming to the next option, 5 plus 2x. 5, option 5 I am taking. The remaining you do as homework. And I will explain also. 5 plus 2x. So just you can do in the writing page itself. Then we get 2x equal to minus 5 and x equal to minus 5 by 2. So first of all we have to find the 0 of the given divisor. So here divisor is 5 plus 2x and 5 plus 2x equal to 0. Then 2x is equal to minus 5 and x equal to minus 5 by 2. That you know how to transpose and all. Every time we are explaining. And now, here p of x, the same p of x only, and the divisors only coming different. So the p of x when divided by, when p of x is divided by 5 plus 2x, okay, the remainder is what? P of minus 5 by 2. So what you get for x, the variable, that value you have to put like this, p of minus 5 by 2. So you have to find the remainder means p of minus 5 by 2 is equal to, you have to substitute in the polynomial p of x. What is there? Here, the same problem. So here I will take p of x. Okay, but if it is separate, we have to write like this. So p of x, instead of x for minus 5 by 2, here minus 5 by 2 whole cube, and then plus 3x square. 3 into minus 5 by 2 whole square, and then plus 3x. So plus 3 into minus 5 by 2, and then plus 1 is there. Plus 1. Okay. So now minus 5 by 2 whole cube. So for minus sign, if we apply cube, what you get? Minus. So that is minus. And then 5 by 2 means 5 cube. What you get? 5 into 5 into 5. What you get? 125. 125 by, and if you apply cube for 2 in the denominator, okay, 2 into 2 into 2, we get 8. So minus 5 by 2 whole cube is nothing but minus 125 by 8. And then plus 3 into minus 5 by 2 whole square. So if you apply square for minus, what you get? Plus. So you leave it. And 5 square becomes 25. And the denominator 2 square becomes 4. And here plus into minus, minus 3 into 5, 15, and then by 2 plus 1. Is it clear? Okay. So now minus 125 by 8, you write all those things. And then plus 3 into 25, you see the numerator 3 into 25 becomes 75, 75 by 4, and this is minus 15 by 2, and plus 1 is there, you write as it is. And then you have to take LCM to simplify this. So what is the LCM, can you tell me? The LCM is 8. You see, the denominators are 8, 4, 2. For all these, the LCM is 8. Do you have any doubt to find the LCM also? I hope you know how to find the LCM. So here 8 is divisible by 4 and also by 2. So the bigger number 8 among 8, 4 and 2, 8. Okay. Because 4 is a divisor of 8, 2 is also divisor of 8. So you can take 8 among 8, 4, 2 as LCM. Okay. So 8. And here we have to write the same minus 125 because the same denominator only. The denominator is equal to LCM. So minus 125 and then plus. What happens? 4 2s are 8. Therefore 75 into 2, 150. And then minus 15 by 2 means 2 is in the denominator. So 2 into 4 is 8. Then only it will be equal to LCM 8 if you multiply by 4. So the numerator also multiply by 4. So 15 into 4 is 60. And then plus. So here comes the denominator 1. So 1 into 8. So numerator also 1 into 8, 8. That's all. You see how I found all this. So now the negative values you see minus 125 minus 60. It becomes minus 185. And then the plus value you see plus 150 plus 8, 158. Okay, divided by 8. Clear? And what you will get? Minus 185 plus 158, you will get minus 27 by 8. Minus 27 by 8. So this is the remainder value. The remainder is minus 27 by 8. P of minus 5 by 2 is the remainder and minus 27 by 8 is also the remainder. But this is by theorem, we are saying P of minus 5 by 2, which is nothing but which is equal to minus 27 by 8. So this is the value. The remainder is minus 27 by 8. So this is the way of finding the remainder when P of x, the polynomial, is divided by another polynomial. Clear? And rest of the sums you take as homework. There are options I will just say. You see, x minus 2 is the option 2. So x equal to 1 by 2 you will get. And then x, option 3 is x. So x means x equal to 0. That only you are going to do. So x equal to 0. So p of 0. We have to substitute 0 for x. And then x plus pi. You see, option 4, it is given that x plus pi. So if you try to find the value of x, what you get? X plus pi equal to 0 and then x equal to minus pi. That's all. So you have to just substitute minus pi for x. So whatever it comes, you write. Okay. So that is the way of doing. And coming to the next sum, question number 2. You see, question number 2. Find the remainder when x cube. So you have to take, let p of x is equal to x cube minus ax square plus 6x minus a. So this is what the polynomial given there, and I am considering the given polynomial as p of x. So find the remainder when p of x is divided by x minus a. So you have to find the remainder when p of x is divided by x minus a. Okay. The remainder is what is the remainder? P of a, that you know. This implies P of a equal to, just substitute a instead of x. What happens? A cube minus a into, instead of x we put here also put bracket, and here instead of x a and then whole square plus 6 into, for x we have to put a and then minus a. You see how I am writing? A cube means a cube only, and then this is minus a into a square only we will get. Okay, so a into a square again a cube and then plus 6 into a 6a and then minus a. So here a cube minus a cube gets cancelled, and this is 6a minus a, that means 6a minus 1a, like that we can understand. So you get 5a. 5a is the remainder when p of x, the given polynomial, is divided by x minus a. Clear? Very simple. And then third sum, it is given there to check whether 7 plus 3x is a factor of 3x cube plus 7x. So it is given a cubic polynomial. Okay, anyhow, so you have to consider, let p of x is equal to the given cubic polynomial is 3x cube plus 7x. 7x. So when p of x divided by, so what is the divisor? 7 plus 3x. The remainder is, to find the remainder. The remainder is what? You have to find in the rough column. So you have to equate 7 plus 3x equal to 0. The method of finding is 0. So 7 plus 3x is equal to 0. So 3x equal to minus 7. So x equal to what? Minus 7 by 3. You know how to find this 0. So this is the way. So you can take p of what? Minus 7 by 3. So this is the remainder by remainder theorem. When p of x is divided by 7 plus 3x, then remainder is p of minus 7 by 3. So just if you try to find p of minus 7 by 3 is equal to 3 into, for x minus 7 by 3 whole cube, and then plus 7 into minus 7 by 3. Clear? So what you get? 3 into minus, if you apply cube you get minus, so within bracket put minus, and for 7 into 7 into 7, what do you get? 7 into 7, 49. 49 into 7 you get 343. So many times we come across this 7 cube, so 343, and denominator 3 cube, you get 27. Okay, and then this is plus into minus, so put minus. 7 into 7, 49 by 3, and this, this 3 numerator, this 27 is in denominator, so you can cancel by 3 table and you will get 9. So here comes the simplification. So listen carefully how we are simplifying it. And this is equal to minus 343 by 9 and then minus 49 by 3. Okay, so here the LCM is what? 9, and the numerator first part you have to write the same, minus 343 minus 3 into 3 is 9, which is equal to the denominator. So in the numerator you have to multiply by 3. So 49 into 3 you will get 147, I think. So this is nothing but 490 by 9. Minus 490 by 9, which is not equal to 0. Clear? 490 minus 490 by 9, which is not equal to 0. Therefore, you can easily say that 7 plus 3x is not a factor, since the remainder is not equal to 0, comma, what? 7 plus 3x is not a factor of the given polynomial p of x. Clear? So now, when the remainder is not equal to 0, then the divisor is not a factor of the given polynomial. Here the divisor is 7 plus 3x, and when we divide the polynomial by this 7 plus 3x, we got the remainder as minus 490 by 9, which is not equal to 0. So we come to the conclusion that the divisor 7 plus 3x is not a factor of p of x. So when we say a divisor is a factor, when we get the remainder 0. We can understand this by the simple constant. You see, 10 divided by 5. So 10, if we divide by 5, 5 2s are 10, the remainder is 0. Clear? Now we can write by division algorithm, 10 is equal to, the divisor is 5 and the quotient is 2, and then the remainder is 0. 5 into 2 plus 0. So now we can say 5, okay, is a factor, and also 2 is a factor. When we divide by 5 also, the remainder gets 0. When we divide 10 by 2 also, we get the remainder 0. I am not talking about the quotient, remainder only. So when the remainder is 0, then we say the divisor is a factor of what? The dividend. So here we can say 5 is a factor of 10 because the remainder is 0. Clear? In such a way, here the remainder we got a non-zero. Okay, that means not equal to 0. So we come to the conclusion 7 plus 3x is not a factor of p of x. So the next topic is factor theorem. Okay, this conclusion will help you to understand the factor theorem, and we will see in the next class. Thank you.